Okay, so let's look at this first one together. All right, so they told you triangle ABC was similar to DFE. So DFE is going this way, right? ABC is going that way. We're trying to find X. So what you have to do is make sure you understand which side X goes with. So in this case, do you guys agree that DE are the first and last letters there? See what I mean by that? Now, sometimes you may be able to pick it out from the picture, I realize, but if you look at the similarity statement, see there's D and E, that's X, right? So X has to go with AC, which is 3. Does everybody see how I did that? Sometimes you can see it from the picture, but if you're struggling to see it from the picture, if you look at the similarity statement, they've got to match up. So now I need to figure out which one of these other ones I want to use. Okay, why can't I do 5 and Y right now? Yeah, I don't have anything to solve with, so I'll have to do that later. But I could do the 10 and 7, because 10 is EF, 7 is CB. See how they're in the same place? So I could put 10 over 7. Now you could cross multiply with that. I could figure out the Y by setting up this with the 10 over 7 also and cross multiply there to find Y. So if I do 7 times X, 3 times 10, X is 30 divided by 7. 7Y equals 50. The Y would be 50 divided by 7. Okay, is everybody good on that one? Okay, let's look at this next one. All right, now I don't have the picture drawn up here, but this one is going to help you when you try to figure out how to set this up to solve for Z. Because to figure out what Z goes with, if you look at this, it will help you. So what I mean by that is Z is the S and U, right? You guys agree with that? Everybody see what I'm talking about? That's the last 2 letters, isn't it? That means it has to go with the L and P, which is 6. So the Z and the 6 have to go together. And then I got to find 2 that have numbers so I can actually set up a ratio. And the 10 and 15 go together. Now, if you want to know what the scale factor was, you would have to take this side, 10 over 15, simplify it, and you would have the scale factor. So all the scale factor is a fancy way of saying what's the ratio of one to the other. So you need 2 sides so you can compare them. And then here now you can just solve it. 15 times Z equals 6 times 10. So your Z would be 4. And this would always have to happen. If I took that 4 and plugged it back in here, 4 over 6 is still the same as 2/3, isn't it? Because it has to stay in the same ratio. Okay? I'll come back to 7 here in a second. We'll do it and make sure you got it. But on number 8, I just want to ask you a question. Is there any way for circles to be different shapes? No. Remember we said at the beginning, similar figures have the same shape, just different sizes? So what we're really saying on number 8, if you have a circle, they will always be proportional. Every circle is proportional to another one. Okay? All right, I do want to go over this last part. Similar figures. If they throw out a 3D shape, it still works the same. So everybody look down here and fill in. To be similar, figures corresponding dimensions have to be proportional or reduced down to the same scale factor. They have to be proportional or reduced down to the same scale factor. So if you look at the very first one, 8A, you guys agree that 4 and 6 are both the diameters of the circles. So whatever they reduce down to has to be the same as 8 over 12. So here's the way I'm going to show you to check to see if it works. If I put 4, 6 and put it equals 8 over 12, when I cross multiply, they have to equal. In other words, 4 times 12 has to equal 6 times 8. If they do, you know they're proportional. If they don't, that means what? Yeah, they're not proportional. Does that make sense? So if you set it up like that, that's one way you can do it. So make sure you work on that practice for next week. Okay? I got to hand you the practice, don't I?